All right, we are on page 703. This will be our second to last lesson. We're going to go from 703 to 705, skipping around, but I think overall completing 4 problems and then getting to our assignment on 707. We're working with still the volume of a sphere, so we worked on this with our guided notes, where the volume is equal to 4/3 pi r cubed now, right? Now, when you have a fraction, the numerator always multiplies and the denominator always divides. Okay, like if you're trying to find what is 2/3 of, let's say, 6, you multiply it with 2 and you divide it by 3. So I mean, well, what's this? Right, 2 times 6 is 12. 12 divided by 3 now. 12 divided by 3 is 4. So 2/3 of 6 is 4. Okay. Anyways, so really think about this. You're multiplying with that 4. You're dividing by that 3. Okay. All right, we're going to start with an easy problem. Well, number 1 is we're going to calculate the volume of the Earth. So number 1, it says the Earth has a diameter of approximately 7,926 miles. So right, this gives us something that is helpful, the diameter, but the thing is, we want to know what the radius is. When we use our formula, there's nowhere where, right, there's no D at all, but there is an R for radius. So let's figure out what R is by dividing this by 2. What is 7,926 divided by 2? 7,926. 7,926 divided by 2. 3,963. 3,963. Hopefully I got that right. 3,963. Okay. Now the diameter says, right, from end to end of the Earth, right, the spherical object. Maybe I would assume it's including the atmosphere as well. Right, almost 8,000 miles. So think about how long it takes you to run a mile, and now multiply that number by 8,000. Okay. But our radius from the center of the Earth to the edge of the Earth, we're thinking about atmosphere, that's almost 4,000 miles there. Just to get a kind of gauge, from the far left of the United States to the far right of the United States, that's about 3,000. I think it's 3,000. Or is that 300 miles? You know what? Let me Google this right now. What is the width of U.S. in miles? Yeah, almost 3,000 miles from far east to west of the United States. Okay, so this is talking about center of the Earth to the atmosphere. All right, but let's plug this big number in. We're going to use the formula for the volume of a sphere. So 4 pi r cubed. I'm actually just going to put this in for r right now. All divided by 3. We're going to get a huge number. This is going to be insane. We're going to multiply 3,963 times itself 3 times. Okay, cubed. There you go. Oh my goodness. What have we done? I'm going to do the other steps too, because I don't think I can get on my calculator. So let's put the steps here, right? I know the formula's right here, but what's the first thing you do? Is you cube the radius. After that, what I typically do is I multiply by 4. That's from our coefficient. And then what I typically do is I divide by the denominator, divide by 3, and then multiply with pi. So I'm going to do that all in the calculator here. So we already did r cubed. Check. I'm going to multiply that by 4 times 4. Enter. Big number. Now I'm going to divide by 3. Hopefully make it a little bit smaller. Divide by 3. Ooh, look at that small number. And then now I'm going to multiply with times 3.14. Okay, what is this number? This is hundred, thousands, millions, and it looks like billions. Oh, I can copy this. Okay. Let me write that number over here. All right, let's take our time making sure that we have this right. So the volume of the Earth is 260, comma 579, comma 713, comma 159. And we're gonna go cubic miles. Okay, we could have rounded in there as hundredths place, but this number is so big we don't even, the hundredths place is insignificant. So it says 260 billion cubic miles. So think of a cubic mile, right? How long it takes you to run a mile, right? If you run that for the length of a cube, and then the height of the cube, and then the width of a cube, you need 260 billion of those cubes to fill up the Earth. So, right, that just shows like how big the Earth is in comparison to us. So, big number. All right, let's move on. We're gonna skip number 2, go to number 3. Now we're gonna adjust number 3. 3 wants us to find the circumference of a baseball, Major League Baseball. So we got a ball here. It wants us to find the circumference, which is this red area here around a ball. But what we're just gonna find is from the center of that ball to the edge of the ball. How long is that? Okay, so now we're going from really big to pretty small numbers in comparison. We're seeing that the volume is 12 and 77 hundredths of a cubic inch, and we're gonna find the radius. So first of all, as always, we rewrite the formula. And really what you're thinking of is, since I'm trying to find the radius, I'm gonna go in reverse order potentially in this. But let's plug in 12.77 for the volume. This is not in terms of pi, so we will have to divide by pi at some point. Let's write SADMEG, reverse order of operations. This 3 is dividing. The 4 is multiplying, pi is multiplying, and then we have an exponent. We need to get rid of it in that order. So let's get rid of dividing by 3. Multiply both sides by 3. .77 multiplied by 3, 38, 31. Okay, these cancel out. Now we're going to do 4 pi r cubed. I'm going to do this actually one at a time. I don't typically do this combined, but I'm just going to only divide by 4. Let's divide our previous result by 4. So divide 4, enter. We're going to round to the nearest hundredths place, so this will go 9.5. The 7 in the thousandths place will make the 7 in the hundredths place go up, so 9.58, so $9.58. All right, equal to pi r cubed. Right, so we did get rid of division. We got rid of one multiplication. We got to get rid of the other multiplication. We're multiplying by pi, so I'm going to divide both sides by 3.14. I'm actually going to write it out here. So let's divide that previous result by 3.14. Divide 3.14, enter. All right, this is about 3.05, so $3.05. All right, running out of room. 3.05 equal to r cubed. And if you remember now, is the thing that's a little bit new. We're taking the cube root, which looks like a square root with a tiny 3. Square root with a tiny 3. We're trying to figure out what 3 numbers, all the same number, that if you multiply by itself equals 305. So how I do that on the calculator here, I press the 3. I press this top left, second from the top left button right here. So it's this button right here. Let me clear that. 3. Oops. 3 of 3.05. Enter. This is about 1.45. 1.45. Okay. So what this means is from the center of a baseball, it's about 1.5 inches from the center of the baseball to the edge of the baseball. So from the center, it's equidistant to any part of the exterior surface area of the edge of the baseball. Okay, about 1.5 inches. So you could say like the diameter is double that, so the diameter is double 1.5, so that's about 3 inches in diameter, and you can find circumference if you want to. But let's move on to the next page. Next page, we're only doing one problem. We're skipping 4, skipping 5, going to 6. Okay. All right, let's look at the context. So it says the world's largest disco ball hangs from a fixed point, and a 5-ton hydraulic rotator powers it. So this is the largest disco ball in the world. It weighs nearly 1.5 tons with a volume of approximately, this is going to be important, 67 cubic meters. So, right, it's 67 of these cubes, that's a meter tall. The disco ball weighs about 8,100 square centimeter, or sorry, contains around 8,100 square centimeter of mirror tiles and over 10,000 rivets. I don't know what that means, but so with this, you have to be careful. These other numbers here, they may seem important, but they're not. These are what are called red herrings. Red herrings is information that a problem gives you that is not necessary to complete that problem. We only need one problem or one number here, and that is the volume, because what we're trying to calculate is the radius. So all these other numbers, ignore, but it's your task to figure out which numbers are important. In this case, we only need one number. So again, let's rewrite. I'm going to erase volume and put 67. All right, so just like the last problem, I'm going to multiply 67 times 3. Right, because I'm undoing dividing by 3. This is 201. This cancels out. 4 pi r cubed. Let's divide this by 4. It's going to be around 50. Divide by 4. Yep, 50.25. All right, so now we're left with pi r cubed. Let's divide both sides by pi. So we're going to round that. We're actually just going to say this is 16, even though it's not exactly 16. I'll put this over here. 16 equal to r cubed. Take the cube root of both sides. So what three numbers, if you multiply it together, is equal to 16 approximately? So cube root of 16. 2.5. We'll say it to the tens place. It's about 2.5. We'll say approximately. And this is in terms of radius. So 2.5, 2.5 meters. So meters is about waist high, or if you look at the door of the class, the door handle is 1 meter. So 2.5 of those is how, from the center of this disco ball to the edge of the disco ball, that's how big it is. Okay. All right, and then let's move on to our last problem. Last problem, we're skipping number 7, going to number 8, and then calling it there. All right, again, we have some red herrings. It says the world's largest ball of twine, so twine just kind of wrapped on itself, is in Darwin, Minnesota. It weighs 17,400 pounds. Francis A. Johnson began creating the ball in March 1950, spending 4 hours a day, every day wrapping the ball. It took Francis 39 years to complete. Upon completion, he moved to a circular open-air shed in his front lawn for all to view. Number 8. Suppose that the volume of the world's most massive ball of twine is 7,234 and 56 hundredths of a cubic foot. Determine the length of the diameter. So we need the radius in order to find the diameter. Oh, that's interesting. At some point, a crane had to lift the ball to continue proper wrapping, to continue putting twine around it. All right. So let's put that this is equal to 4 pi r cubed divided by 3. We're going to multiply both sides by 3. So 3 times 7,234.56. Enter. 21,703. And I didn't get the hundreds place. 68. This goes away. Should probably draw the line down the middle. 4 pi r cubed. So divide both sides by 4. Okay. 5,425.92. So 5,425. 5,425.92 equal to pi r cubed. Let's divide both sides by pi. All right, this is exactly 1,728. So 1,728. Let's put it over here. So 1,728. Equal to pi cubed, or sorry, r cubed. So let's take the cube root of 1,728. This is 12. Okay. So I'm not gonna box this, but also I wanted to show something. If you cannot find the cube function or cube root option on a calculator, you can always just Google cube root calculator like I did over here. Don't use this calculator, but let's click our first entry here, calculator soup, click that. So if we wanted to find the cube root of 1,728, then you press calculate, it gives us the same thing, right? It's also 12, 12 right here. Okay, let's go back. Now the thing is, it asks us for the diameter, right? So the diameter is double the radius. It's radius plus another radius. So our diameter, what we want to find is 24, and this is in terms of cubic feet, but you don't put cube, you just put feet. All right, so that's going to conclude this section of notes on 705. On our assignment on 707, we're doing the numbers 1, 2, 3, and then 5. So 1, 2, 3 on the front side. Actually, you know what? Yeah, and then 5 on the back side. Just want to talk about number 3 though. It says the circumference, right? The formula for the circumference of a circle is 2 pi r. So for this problem, it says the circumference is this. Make sure that we plug that in for the circumference. And then to figure out the radius of this, divide by 2 pi to both sides. And then whatever this is equal to will give you your radius. But use that to find the volume for number 3. Anyways, so 1, 2, 3, and 5. Let me know if you have questions.